Okay, so we're going to talk about, for at least the beginning part of this week, angles outside of the circle. So anything that's formed outside of the circle. And I have three pictures here, which I'm going to erase and redraw. I want you to see how I did it. So you see this angle right here. That little angle there is formed by these two secants. Remember, secants poke through the circle. They're like chords that get extended past the circle. So those two secants formed an angle way out here. And then we have a secant and a tangent. So this is a tangent, this is a secant. They form an angle out there as well. Almost the same thing, except one's a tangent and one's a secant. Or you could have two tangents, meaning you have one piece bumping into the circle in one place, not poking through it, just rubbing up against it. Same thing here. And then that's going to form an exterior angle, right? So how did I do that to start with? We had a situation where we had a secant and another secant, and they form an angle out here. Now if you notice, from here to here, there's an arc. And from here to here, there's an arc. Those are the two intercepted arcs. Keep that in mind for a minute. What if I drew a tangent and a secant? Still an angle is formed out here. But again, you have this arc right here, and you have this arc right here. The arcs actually touch each other right there. But that's where they change over, because that's the point where the tangent touches. So there's two arcs intercepted there as well. And then if we go back to the third one I had drawn, tangent and another tangent, kind of looks like an ice cream cone. There's an angle formed there. Now in this case, there's an arc that goes from here to here this way. There's that arc, whoops, and then there's an arc that goes from there to there on the other side. So there's two intercepted arcs. And in that case, it takes up the entire circle, but there's still two arcs. You can think about it as like arc 1, arc 2, arc 1, arc 2, arc 1, arc 2. In any of these cases, anytime you have an angle outside the circle, we have two arcs involved. And the formula is that the angle equals the big arc minus the small arc divided by 2. So you just subtract the two arcs and take half of it. Okay, and I'm going to do page 21 right now with you, and Dr. Conklin is going to do page 24 in a separate video attached, which is the varsity version of this. I'm going to give you the junior varsity version as an intro. Okay, so if you need this, you can always go back to it. But that's the idea right there. And this is our formula. The angle on the outside, right here, here, or here, we take the bigger arc, which would be, I called it angle 1 in each one, right? The bigger one minus the smaller one. And then you just divide it by 2. So let's give it a shot on page 21. So in number 1, I have what appears to be a tangent, because it bumps into the circle in one place, and a secant, right? And that formed two intercepted arcs, there and there. So it wants to know, what is the measure of angle P, right? So angle P, which is x, is the big arc minus the small arc divided by 2. 80 minus 60 is 20, divided by 2 is 10 degrees for angle P. Subtract the angles, divide by 2. Subtract the angles, divide by 2. Okay. This one has a tangent again and a secant again. The only difference is what information they gave us. There's a point here, a point here, and a point here. So there's really 3 arcs involved here, right? There's this one that's not labeled yet. There's this one that's 80. And there's this one that's 100. Well, if from here to here is 180, right? 80 and 100 is 180. Well, we need the other 180, right? Because we have to try to get to 360. So it's not because these two added up to 180. It's because 360 minus these happens to be 180. Because there's no other part of the circle, so they all add up to 360 now. So it wants to find angle APB, which is from A to P to B, which is right here. Right? So the angle is, and you don't need this anymore, because these are the 2 arcs that are involved. Right? This is not in this cone-shaped thing here, because we only look inside here. So this doesn't need to be there now. 180 minus 80 divided by 2. 180 minus 80 is 100. Divided by 2 is 50. Same idea, except you had to find one of your own arcs by yourself. Okay, number 3. Don't forget to pause and go back if I'm losing you at all. Again, a tangent and a secant. Okay, but it's true for every one of them. It just so happens we have 3 so far that are tangents and secants. Okay, and notice that there's an arc here, right, and an arc here. And they meet at that point right there. So it says find angle A, right, if arc DC is 120 and arc CB is 170. Careful, it said CB, right? Well, I need this, not this, but I'm going to use that 170. So far, out of the whole circle, I have used 290 degrees, right? An entire circle is 360. So that leaves me with 70 degrees for that. Now I don't need this anymore. Just like the last problem, it's big arc minus small arc divided by 2. Big arc minus small arc divided by 2. Well, 120 minus 70 is 50. 50 divided by 2. Come back. Glitch. 25. For angle A. One more question for me. Another tangent. And a secant. It says, I don't like the way this is drawn because that 40 looks like it could be anywhere. So I'm going to take a minute to clarify this. 40 is really in here. See how it says angle A is 40? So what they really meant, it had a big giant 40 there. It was hard to figure out what they meant. That's 40. So now they're giving us the angle, and they're giving us this arc, and it looks like they're asking us to find arc BC. Well, that's different now, right? This time they're sort of giving us the answer and asking us to find something in the middle. So remember, it was angle equals big arc minus small arc divided by 2. For every other problem, the angle has been the x, but on this particular problem, the angle is given, it's 40. The angle equals the big arc minus the small arc divided by 2. So now this is going to be a perfect segue into the algebra that we're going to review for next year. But to clear the 2 on the bottom, I'm going to multiply both sides by 2. So that gets rid of the 2 in the denominator. So now I have 80 equals 140 minus x. And I'll take away 140 from both sides, which is negative 60 equals negative x. But then if they're both negative, then they're both positive, because you divide by negative 1. So 60 is the answer. And if you want to double check it, if we put 60 here, 140 minus 60, right? 140 take away 60 is 80, divided by 2 is 40. So remember, the moral of the story here, these four all happen to be secants and tangents, but anytime you have an angle outside of the circle, you just subtract the two arcs and divide by 2. Subtract the two arcs and divide by 2. Dr. Conklin is going to take page 24 with you now. Don't forget to upload your notes as an assignment by Wednesday. Thanks.